This is Pre-Calculus Concept 33F. We're going to look at solving trig equations one more time. This time our problems are going to require some calculator use. So let's jump right in with an example. Sine of x equals 1/3. It's asking us to find the angles x, that when I take the sine of that angle I get 1/3. And right away some alarm should go off because 1/3 is not a common unit circle value that we've seen in previous problems. So we actually have to use our calculator to solve this. And hopefully you remember that the way to find an angle, if you know its sine, is to use the inverse sine operation on your calculator. So if you don't have it, grab your calculator, pull it on out, make sure you're in meridian mode, and tell us what you get for that value. Alright, hope you got what I got, which was about 0.34. And here's the other twist to these problems, is that the calculator can only give you one answer. So if I think about a picture, there's somewhere where the y-coordinate is 1/3, and we're figuring out that that angle is about 0.34. I'm going to go ahead and approximate 0.34. But just like with our other trig problems, we want to keep going around the circle and think about the fact that there's another angle on the other side. Rather than reading this off your unit circle, we actually have to calculate this angle. The good news is that the two answers have the same reference angle. So in other words, if I think about that distance and this distance, it should be the exact same thing, because in those two locations the y-coordinate would be the same. So knowing that one of my answers is 0.34, I can actually pretty easily calculate the other one, and you might have guessed how. This second angle is going to be x equals pi minus 0.34. Okay, and so that one, when you work it out, ends up being about, let's see, minus 0.34. Sorry about that. You get about 2.80. So it ends up in this problem that those are our two answers. This would be a good time to check. If you took 0.34 and you plug it in your calculator, you should get about 1/3. Remember, we rounded, so it's going to be a little bit off. Or if you took 2.80, your answer should also be about 1/3. Alright, every function is going to be a little different because I have to think about where my answers would lie. So sometimes it may be helpful right off the bat to think about the quadrants in which your answers should lie. So I'm going to think about an angle whose cosine is 0.2, and that's going to require me to do the inverse cosine of 0.2. I'll do that in just a second. But I should realize that since the cosine is positive, my answer should be in the first quadrant and in the fourth quadrant. So let's pull out our calculator again. We'll see what our calculator gives us for the inverse cosine function. Oops. Hang on one second. Alright, and I get 1.37 in this case. And once again, that is the first quadrant angle, 1.37, that our calculator is giving us. You might guess that I need to find that one, and I'm going to find it in a different way than how I found the second angle in the sine problem, because the angle's in a different place, right? But both of those angles have the same reference angle of 1.34. So my answer in the first quadrant, the calculated answer 1.34 is one of my answers. I'll say approximately because we're rounding. And then I also have another one that hopefully realize is going to be 2 pi minus 1.34. So working that out real quick, I get a second answer of 4.94. Okay, another pretty easy problem to check. If I took either one of these and I plugged it back in the equation, I should get something pretty darn close to 0.2. Alright, let's look at a couple more examples. These are similar, but they're a little bit harder because the value given is a negative value. So let's start off with a little diagram. I don't know what this angle is, but I do know that the answer to this problem has x values that are negative. Right, so that automatically tells me second and third quadrant are going to be my answers. And our calculator is going to give us one of those, and then we're going to have to figure out the other. Alright, so when I do inverse cosine of negative 2/3, you get a second quadrant answer, so that's going to be about 2.3. And then I have to think about how on earth I could get this angle. And there's a couple different ways you can get it, but kind of the easiest way is to think about going in this circle in the forwards direction. And you're going to go not all the way around, but you're going to go 2.3 radians short of all the way around. So again, I think it helps to think visually about what your answers would look like. But in this case, x is going to either be the second quadrant angle, approximately 2.3, or it's going to be 2 pi minus that. 2 pi minus 2.3 would be that second angle. So when I do that, I get approximately 4.0 is what it turns out to be, approximately. Oh, just realizing that it asks us to do 2 decimal places, so I should actually keep the second decimal place there. And I end up with something a little different here. It actually ends up being 3.98 for my answer. Okay, let's do one more. Inverse tangent of negative 6. Let's draw a quick picture for this one. The tangent is negative in the second and the fourth quadrant, so I should expect my answers to show up in those quadrants. This is going to be a little bit different. You may remember when I do the inverse tangent of a negative number. Okay, so remember what we know about inverse tangent? I actually get a answer that is in the fourth quadrant, but it's named downward, right, or negative 0.4. And that's actually not super helpful because my problem is to name the angles in the forwards direction that has a tangent of negative 6. The good news is that reference angle is going to be important, so I'm going to call that one negative 1.41 and realize that my angles that I'm looking for are going to be that distance away from the x-axis. So in other words, the angles I'm looking for are going to be that much short of 2 pi and also that much short of pi. And when you think about it that way, we can come up with our answers. So locating the angles and thinking about them in relation to the reference angles are important. So x is going to be approximately pi minus 1.41 and approximately 2 pi minus 1.41. Okay, and I'll go ahead and just leave my answers like that this time, but I can figure them out on my calculator if I need to. Alright, let's have you do a U-try. You're going to think about all angles in one trip around the circle whose sine is 1/4. Take a minute, see if you can figure this one out. Alright, so again, an unfamiliar value, so I'm going to have to use my calculator and do the inverse sine of 1/4. I get a radian measure of about 0.25. My little picture over here shows me the quadrants that I would expect my answer to be in. So first and second quadrant is where the sine is positive. And the reference angle to both answers is going to be that value that I got, 0.25. So the first quadrant answer is 0.25, and the second quadrant answer is going to be pi minus 0.25.